This is Algebra 1, Lesson 35B, Canceling. We're going to do examples 35.6 through 35.9. This lesson is so important. Many algebra students look at canceling as though it is some magic thing, and it is not. Let's look and see if we can figure out what canceling is. You've probably used that term before, but do you know what it really means? So let's look at this little equation. If you had 4x equals 20, you would know immediately, oh, it's got to be 5. Right. But how can you show algebraically that that's true? Well, you're multiplying the variable by 4, so let's divide by 4. And we would need to do that on both sides to keep it balanced. 4 divided by 4, we mark those out, right? X equals 20 divided by 4, which is 5. So there's algebraically why. But this whole business of marking that out, you're canceling. You're saying 4 divided by 4 is 1. So those essentially, it's just a 1x. Or you could say there's a 4 on top here. How many 4's in here? 1. How many 4's in here? 1. You see how it becomes a 1 over a 1, which is just 1? That's the idea of canceling. But what allowed us to do that? Well, we were able to do that because we have a multiplication here, 4 times x, and it's divided by 4. And you could think of this as like 4 times 1 if you wanted to. And we can say, oh, 4 times x, 4 times 1, they both have a common factor, right? And we end up with x over 1, which is just x. So you can see, or maybe hopefully starting to see from this example, that canceling is really division, okay? So let's look at another example. We can call that canceling, but what is canceling? And like I said, it is a division, okay? Can we cancel here? A lot of students will say, well, Mrs. Hill, you canceled that 4 and that 4, so can we cancel this 4 and this 4? Well, that's a really good question, and I'm so glad you asked. Okay, can we cancel here? Well, before, in this problem, we had here a multiplication. So the inverse operation was division. Do you have a multiplication here? No. So remember, canceling is division. So can we cancel those 4's? That would be like saying, oh, they're adding the opposite. The inverse operation is dividing. No, it's not. So you can't cancel in this situation. So I've shown you where you can cancel, and I've shown you where you can't cancel. Let's try to hone that in a little bit more. Let's look at another example that looks very similar. In this example, they have 4 multiplied by x plus 1. So here's a factor. Here's a factor. Looks kind of strange because that factor has 2 terms, right? And then we have a number in the bottom. Now we could say that that's like times a 1, right? So in the top we have 4 times something, and in the bottom we have 4 times something. So we could divide the top and the bottom by 4. There's canceling. Why can we do it here, but we can't do it up here? Because up here, this is not a multiplication. You can only cancel, because remember, canceling is division, when there is a multiplication, okay? If you're still not getting it, hold on. We're going to get there. We're going to look at it a little differently. Here's a definition. Cancellation is possible when the numerator and denominator contain one or more common factors. Well, you know what factors are. Factors are numbers that you multiply together to get another number, a product. So you can't cancel unless you have a multiplication, okay? All right, so if you have no common factors, you can't cancel, okay? Let's try a few examples. Example 35.6. All right, let's look. We got to see if we have multiplications. We've learned that's important. All right, this is a factor times this. And then in the bottom, we just have this, but we can think of that as times 1. So now we have factors in the bottom. So we have multiplications going on here. So that means we can divide. So let's divide the top by 4, and then let's divide the bottom by 4. And we end up with 1 times a minus 3 which is just a minus 3, over 1, right? But doesn't that just simplify to a minus 3? That is an appropriate time to cancel because we had a product. And the numerator and denominator had common factors. Remember we talked about here, common factors. Okay, let's look at B. We have a multiplication. This times this. All right, so we can see it clearly, put this in parentheses and pretend like it's a times 1. Because we can do that, right? Times 1 doesn't change it. So we have a multiplication in the denominator, right? So what are the common factors in the numerator and denominator? This time it's the expression. So we end up with, on the top, 3 over 1, which is more simply put as 3. The answer there would be 3. Let's go on to example 35-7. Uh-oh. I see a product here, but I can't just pull out the product. I need it to be an all product, one big product in the top. But wait a second. In the previous video, we learned about factoring. And factoring is just taking an addition and rewriting it as a multiplication. And then that would mean that I would be able to cancel because I would have a multiplication. So let's try that. Let's factor the numerator. Do you see the common factor of those two terms? Write the GCF out in the front. Like a reverse distributive, right? Inside of these parentheses, what would I have to put to where when I multiply it out, I get 3p plus 3. So 3 times, this is going to have to be a p, plus, what would I have to multiply this 3 by to get this 3? Well, there's going to need to be a 1 there. So let's distribute that. So we're sure we got it right. 3p plus 3. Yep, we got it. Now we have factored that numerator so that we now have a multiplication. Two things that are being multiplied. Now this thing looks more like two things, right? But we have it in parentheses. The whole thing is multiplied by the 3. In the denominator, I have a 3. Okay, again, this is like a 3 times a 1, if you'd like to think of it that way. So in the numerator, I have a 3 times p plus 1, and in the denominator, I have a 3 times 1. What's the common factor? It's the 3. Right? So I end up with, in the numerator, 1 times p plus 1, which is just p plus 1. And in the denominator, 1 times 1, which is just 1. But more simply put, your answer would just be p plus 1. Let's look at example 35-8. Oof, we do not have a multiplication in that numerator. We've got two terms and it's not listed as factors. So we can factor it. Let's factor it. What do they both have in common? Let's look for a GCF. Looks like they have a 3 in common. And it looks like they have an X in common. Okay, let's finish factoring it. New skill. We can do it though. 3 times something is going to give me 3x. Or I'm sorry, 3x times something. Well, 3x times, what would I put? 0? No, because 3x times 0 would be 0. 3x times 1. 3x times 1 would give me 3x. That'll work. Now I see here I'm going to need this minus. Okay, so I'm going to have a minus here. Now, 3x times something is going to give me this 9x squared. It's going to need to be a 3 and an x. 3x times 3x would be 9x squared. All right, great. Now the numerator is factored. Now we have a multiplication. Here's a term, a factor, I should say, not a term. Scratch that. And here we have a factor, okay? And then here we have a factor. They are being multiplied by each other. And in the denominator, I have 3x. And if you'd like to think of it this way, so it looks like a multiplication, right? 3x times 1. Now, 3x and 3x, common factors between the numerator and the denominator. So we end up with 1 times 1 minus 3x. So we have just a 1 minus 3x in the numerator, and we have a 1 times 1, which is just 1 in the denominator. So here is your simplified form for 8. You're doing a great job, and you are almost done. Let's do the last example. I bet you've got this, right? All right, looking in the numerator, I see a subtraction. I don't see a product. I need a multiplication so that I can see if I can cancel, right? All right, so we're looking at our first term and our second term. What do they have in common? Looks like they have a 5 in common. It looks like they also have an x in common. All right, great. Now, that's what I'm going to factor out, okay? So it's the initial factor here. Now I'm going to have over here, this has 2 terms, so I'm going to have 2 terms here as well, and a minus sign between them, okay? 5x here times something is going to give me 5x. What do I put there? Well, 5x times 1 would give me 5x. All righty. 5x times something is going to give me 25x squared. Well, 5 times 5 is 25, and x times x is x squared. Awesome. Now I have a multiplication in the numerator. Whoops. Let me erase these. Too many lines, right? So I have a multiplication. This times this. All right. Now let's look at our denominator. It's just 5xy. And you can think of that as times 1 if you would like. Now, what do they have in common? Well, here are my 2 factors. This times this. What do they have in common? Well, they have a 5 in common. So let's divide by 5 or cancel the 5. How many 5's in here? 1. How many 5's in here? 1. All right, now look at this x. How many x's are in x? That's going to cancel with this one. But the y does not cancel because there's no y in the numerator to cancel it. So what do we have here? We have 1 times this, which is just equal to 1 minus 5x. All those 1's times each other, right? And then in the denominator, what do we have? Well, we have a 1 times a 1 times a y times a 1. All those 1's multiplied by each other times the y is just a y. And that y does not cancel because there's no y factor in the numerator. So this is your simplified form of this expression. You made it. Good job.